Hey guys, and welcome back to our flipped video lessons here. So we've worked a lot with single variable linear equations. We did 1 and 2 step, we did our multi-step with parentheses, like terms on the same side, variable terms on both sides, we did fractions, and we did absolute value bars. So now we're going to look at some equations that we are going to be using the zero product property to solve. So let's review quickly what the zero product property says. The zero product property tells us that if we have multiple factors equal to 0, then at least one of those factors, but possibly all of those factors, could be equal to 0. So if we look at the equation below, we have two binomial factors, x minus 3 and 2x plus 5. The zero product property tells me that one of those binomials, or possibly both, have to be 0 for that equation to be true. Now, one thing about these equations, we do not want to distribute. Distributing will upset the equation in a way that we cannot use the zero product property. Okay? We need the expression on the left written as factors to be able to use the zero product property. So, now that we got that out of the way, let's actually start working with this equation here. So again, what the zero product property is telling us is that x minus 3 is a factor and 2x plus 5 is a factor. And since the product of those two is 0, this tells us that either x minus 3 is equal to 0 or 2x minus 5 is equal to 0. That one of them has to be 0. Since they both contain a variable, we don't know which one is 0, so we have to assume that both of them could be 0. What this allows us is, just like with our absolute value equations, that we can create two equations. Now, we're not doing it in the same way with distance, but because of the zero product property, we are going to have two equations here. You can see our solutions are 3 and negative 5 halves. Notice that there are two solutions here. Why is that? Well, this is because we have a variable in both of our factors. And this is what determines the number of solutions when we're using the zero product property. There will always be the same number of solutions as there are factors that contain variables, right? And since there's a variable in each of these, there's going to be a different value of x that is going to make the equation true based on which factor is equal to 0. For example, if we take the solution of 3 and substitute it back into our equation here. Notice, if I substitute it in for one x, I have to do it for everywhere that there's an x in the equation here. So you can see we have 3 minus 3 in the first binomial and 2 times 3 plus 5 in the second. Well, the first binomial simplifies to 0, the second one 11, and 0 times 11 is 0. Our equation is true, 0 equals 0. That's one solution. But what happens if I plug negative 5 halves in? Well, if I plug negative 5 halves in, the first binomial simplifies to negative 11 halves, but the second one simplifies to 0. Negative 11 halves times 0 is 0, and our equation is true. So you can see, depending on which binomial could be 0, we have two different solutions here. And we have to be able to find all of our solutions when we're solving these equations. So now that we've talked a little bit about this, hopefully we're understanding it. Again, if we have questions on what we just talked about, please write them down. We'll go over them and explain more during class. Okay, so let's look at some examples here. Our first example, we have negative 3x plus 1 is a factor, that's a binomial, and 10x minus 7 is a factor. They equal 0, so that means one of them has to be 0. Since we don't know which one it is, we have to find the solution for each possibility. So we set up negative 3x plus 1 equal to 0 and 10x minus 7 equal to 0, and then solve both equations. And we get our two solutions there. In our second example, we have just x, which is a factor, times 3x plus 12, which is a factor. So again, this is telling me that even though x isn't in parentheses, it's still a factor. It's still being multiplied by 3x plus 12. So this is telling me that either x is equal to 0 or 3x plus 12 is equal to 0, right? We don't have to solve x equal to 0 because it's already alone. The variable's already isolated. For 3x plus 12, we subtract 12 and divide by 3, and we get our two solutions. So essentially what we're doing is we're taking an equation that is already written as the product of factors. In other words, there's a bunch of factors equal to 0, and we're using the zero product property to create an equation for every factor that has a variable in it. In this case, in our example so far, it's been two equations because we've had two factors with variables. So now that we've done a couple together, why don't you try these on your own? use the zero product property to create an equation for each factor that has a variable. So go ahead, pause the video, and solve these equations. Go. Let's see how you did. Hopefully you got these solutions. If you're not understanding where we got these solutions, please come to class and we'll talk more about this, go through the problems, we'll go through the work, and we'll make sure you understand this stuff. Well, until we see you in class, this is the end. So long next time. Bye-bye.